we talk about traverse. Okay, we talk about what we need to measure. Okay, we talk about bearings and angle distance measurement. And if you remember earlier, I was talking about closed and open traverse. Okay, this slide just to show you an example of a closed traverse. If the triangle denotes non-control points, meaning that you've got the coordinates of that point, where there's a circle represent unknown points or points that you need to measure. Okay, so if you look at the first one, at the top one, from there, you start from a known point, you go to an unknown point, measure that point, calculate its coordinate, measure to 3, calculate that coordinate, and so on. And finally, you end up your work at a known point. Okay, at a known point, at a control point. So if that is the case, so this is called, the top one is called as closed traverse. Okay, now look at the one at the on the right, this one here. Again, you start from a known point, then let's say you go clockwise. Okay, so you go first point, second point, third point, fourth, fifth, and finally coming back to the same point. So this is also called a closed traverse. Okay, but for the one on the bottom left, you start from a control point, first unknown, second unknown, third unknown, and you finish your job also at point without known values. So this is called an open traverse. Okay, and talking about closed traverse, geometrically, okay, this is what we term as a loop traverse, because it goes from one point all the way around, okay, coming back to this point. So there's a loop traverse. Okay, whereas that one there, the top one, that traverse here, is called a link traverse. It starts from there, goes to that point, 3, 4, 5, and the last point here. It's also called a closed traverse. It's a link traverse. Okay, so you can either perform a loop closed traverse or a link closed traverse. They're both valid in terms of the work that we normally do. Okay, and we can apply checks. Okay, we can look at how we fare in terms of accuracy, whether the work is accepted or we have to practice a bit more or repeat the work. Okay, right. Then applications. Okay. When do we need traverse? Why do we need traverse? I think the answer to that will simply be we need to provide control. We need to provide the whole. Okay, remember the whole in the basic principle. So that's why we have to provide traverse. So what are they used for? Okay. To give an example, okay, to put it plainly, there are two main purposes, okay, why we need traverse. Okay, first, to provide control point for what? For obtaining the plan. Okay, and normally before we start, before we could take up any design of a project, some kind of initial information required, and one of the things will be a plan, existing the current plan of the area. So from time to time we need to provide we need to produce a plan for the area where the project will take place. And before we could provide the plan, if we could do any management, we have to provide control. So control points to provide or to obtain a plan of the area. And secondly, at the construction stage, these points or the control points are needed for setting out work. Okay, setting out here simply means we're going to put whatever we design on paper or on the computer, depending where you design them, to put it back on the ground. Okay, so in order to put it back at the right place, at the right spot, a right elevation, right position, we need to have some reference. So the traverse point will provide you the reference for your setting out work. Okay, so I've prepared a simple sort of explanation. So let's look at it. Okay, imagine that we have an area here, okay, which consists of shop houses, a parking area, an intersection, and a lake. Okay, and let's say you are entrusted to provide or to produce a plan of the area. So before you could start measuring all the shops and the streets and the parking area, the position of the lake, you have to provide the control. So you will have to go around the area, you establish points like so, the red ones. Okay, the red circle represent points that you have put in the ground, and you think that will be your reference point. So once those points are in the ground, the next step is to find or to determine the coordinates of this point. Then you will simply run a traverse through it. Okay, to all the points, measure bearing distances, do your calculations, and you get all the coordinates of the points. Okay, once those points are established, okay, the traverse stations are established, you can now use them. Okay, you can set up your equipment on them there to measure what we call offsets or distances to the features that we need to map. Okay, you'll measure distances and angles to the shop corners, then you know the position of those shop corners, and you can actually plot it out, draw them, okay, on a plan. Okay, similarly to the lake. Okay, you can get the edges of the lake, then you can get the shape of the lake in the plan. So that's the first purpose of it, to provide control, so for mapping purposes. Okay, let's say that's done. You've got the map. Okay, then it'll be at the design stage, supposing that in the same area with stations that we had previously, it's proposed to build a new building just where it is, next to the lake. Okay, so now the next step will be to determine these corners, to make sure that they are positioned exactly as what we have on the plan. Okay, so which means that we have to do some calculations, and we're going to use the traverse station that we have. Okay, like so. I'm going to measure. Okay, we're going to measure that distance as given in the plan, as given in the design. So the design says the distance from there to there is 20 meters. So you will have to measure 20 meters on the ground with whatever angle that you have designed, and then you can mark that point on the ground. So setting out, this is basically what we mean by setting out. So setting out is basically a reverse of producing a map. Okay, so this is from the map to the ground. Okay, so that's why we need traverse stations, why we need control points, why we need to perform traverse to provide control for the work during constructions. Okay, so that's the purpose. Why? So if you understand why, if you can appreciate why, I think you will understand, okay, why we need to do why traverse is needed, okay, before you're going to start any job. Okay, now let's look at how we go about doing it in the field, traversing field work. Consists of 3 major steps, okay, major steps. It will be more the minor ones, but we're going to discuss about the major steps. First, Reconnaissance, or Recce for short. Okay, what does that mean? You're going to be doing station marking, identifying location, intervisibility. So it simply means you have to walk around the area. Let's say you're given an area, you know what the area is. Just walk around the area. Try to decide where to put your stations, your markers in the ground. Okay, and identify that the point that you've chosen is quite, what should I say, obscured from public, okay, meaning that, okay, you don't put a point in the middle of a footpath maybe, okay, something that people might not bump into, okay, but whatever it is, you have to make sure that the points that you have placed in the ground are intervisible. You can actually see the adjacent stations, okay? Because if you can't see them, you cannot measure the distance, and obviously cannot measure the angle. Okay, so that's you have to spend a fair bit of time doing this. Okay, give a good thought about it. Because planning is important. Okay, if you plan it badly, in the middle of doing your traverse, suddenly you realize that one of the stations cannot be seen from where you are, so which means that you might have to repeat a few measurements that could be like would set you back or maybe an hour or two. So if you plan it carefully, make sure they are intervisible, I think you should be on the right track. Okay, so that's station marking under Reconnaissance. Then angle observation. Okay, you measure the angle using the total station, and you measure horizontal angles to determine the bearings, and don't forget to measure the vertical angle as well. Okay, not to get height, but to calculate horizontal distance, because most likely when you measure angle, you cannot be sure that what I'm saying, when you measure distances, we cannot say that the height of the total station will be the same as the height of the target. So most highly likely, the distance that you measure will be a slope distance. So you need to know what the vertical angle is so that you can get the horizontal distance, because that is the horizontal distance, because that is what we want, okay, when we measure, when we do our calculation, the horizontal distance. Okay, now distance measurement simply means distance between adjacent stations. Okay, so if you're at one station, that means you have 2 distances to measure, one to your back station and one to your forward station. Okay, the neighboring stations, put it that way. And as I said earlier, it's highly likely going to be slope distances. Okay, don't worry about it, because you always have the vertical angle that enable us to calculate what the horizontal distance is. Okay, now let's look at angular observations now. Okay, how do we measure angles. Okay, measuring angles between adjacent traverse lines. So you at one point you're going to have another point to your left, to your right, maybe. So you have to measure the angles between them. Okay, and how do we measure the angle? We got to place targets or prisms, or sometimes called reflectors. Okay, on the back end, forward stations. Okay, let's look at a simple schematic that I prepared. Okay, anyway, before that, it requires two operations. You got to set up the total station over each station. So that means you have to go to each stations that you have established. If you got 7 points, then we expect to see 7 angles or 7 bearings. And you measure total angle between adjacent traverse line, and let's assume that we have put 3 points in the ground, like so, point 1, 2, and 3. And we're going to start measuring angles now. So let's say we're going to be on 2. We call that occupied station. Okay, and let's say point 1 as our back station, and point 3 as our forward station. Okay, we're going to set up our equipment on 2. Okay, the total station on 2. And what we're going to have at 1, on 1 will be a prism or reflector. Okay, and as I mentioned earlier, the height of that prism or reflector need not be the same as the height of the instrument or the total station. You don't have to worry about getting the same height, because at the end of the day, we will be measuring vertical angle. We can always reduce that distance to horizontal distance. And similarly on 3, another set of prism or reflector will be placed. So we'll be measuring, we'll be pointing at 1, turning the instrument to measure at 3, like so. So that means that we will obtain the angle at 2 between 1 to 3. So that's basically the operation required at each stations to measure the angle from your back station to your forward station. Okay, that's another setup, just to show that, you know, prism could come, might not be excuse me, on tripod as I shown earlier. It could be on a simple holder like that. Okay, but again, you still need a back station and a forward station.
انضم معنا الآن واشترك بالقناة ليصلك كل جديد. YSAG، معا نحو مستقبل مشرق.